Assalamu alaikum and welcome back. We are once again tracing one of humanity's great intellectual adventures to understand the sun that we now take so for granted. We had arrived at the point where Galileo realized that the sun has spots. It's not Aristotle's perfect ball of heavenly ether, and where Giovanni Cassini had calculated that the distance from the Earth to the sun was much bigger than anybody had surmised or thought. It was about 93 million miles. From that, it was possible to calculate the size of the sun, given how big it appears to us in the sky. And Copernicus and Galileo had really changed thousands of years of scientific dogma and in fact overturned common sense by saying it is not the sun that rotates around the earth as we think naturally because it rises in the east and sets in the west while we feel like we're standing still, but in fact it is the earth that rotates around the sun. And so it became ever more important for humanity to understand what was this sun. Now Newton returns to the picture. Remember when we talked about the laws of nature, we talked about Newton's law of universal gravitation, that the force between two bodies, the gravitational force, is a gravitational constant times the mass of one body times the mass of another over their radius squared. So, now knowing how far the Earth was from the sun, and knowing how long it takes the Earth to revolve around the sun, 1 year, it was possible to use Newton's law of gravitation to calculate, number one, that the sun had to be matter. It had to have mass. It couldn't be a ball of light without mass. And that this mass was in fact huge, about 332,900 times the mass of the Earth. So then what in the world could it be? The first idea had to do with something called the conservation of energy. Scientists like Joule, Mayer, Helmholtz had discovered that energy is not created or destroyed. It is conserved. It may change form, but one cannot create energy from nothing. And so what was it that gave the sun its energy? One idea, given what we know here on Earth and given the notion that the sun was made of matter and given the notion that we no longer believed it was made of some heavenly ether, was why not a big ball of coal that was 330,000 times or 333,000 times the mass of the Earth, providing light and heat? Well, people could actually make calculations based on this assumption, and they realized that if that were the case, the sun would burn out in about 1,500 years. Even how big it was, but to give off the light and the heat that it does, it would take 1,500, some people said more, 3,000, others calculated 6,000 based on the assumptions, but no matter which way you sliced it, it was only a few thousand years. Not to mention its temperature wouldn't remain constant. As it burned down, its temperature would change fairly drastically, and so it could not be the source of constant radiative energy that kept life on this planet alive century after century. The age issue, 1,500 years or 6,000 years, wasn't so big in the 1600s, because until the 1700s, most people thought the Earth was just a few thousand years old. But by 1750, discoveries in geology had convinced most serious scientists that the Earth was actually now a few million years old, and so the ball of coal idea was no longer tenable. It was about this time that Helmholtz, in the mid-1800s, proposed another theory, that if not chemical energy, if not taking coal and burning it or wood and burning it, well, the sun could derive its energy from kinetic energy, the energy of motion that could supply the needed power to light up the sun. This shouldn't be so odd to us. For example, water-driven turbines that make electricity are taking the kinetic energy of water as it falls down a dam, for example, and using that to produce electrical energy. So Helmholtz postulated that if there are objects in space hitting the sun, if enough objects hit the sun, that could give it the energy it needs, sort of like a meteor hitting the Earth would transfer energy to the Earth. So he again made a calculation and realized that it would require 100 trillion tons of matter to hit the sun every hour to give it the energy it needs. Again, we now know how far it is, we know how big it is, we know the light and heat it gives off, so these sorts of calculations were possible, as amazing as they are. So even though this was a very bright idea, there are problems with this theory. First, when we look with telescopes, it doesn't seem that there's enough matter in space around the sun to do this. Secondly, the sun's mass would increase by 100 trillion tons every hour, year after year. This increase in mass would increase the sun's gravitational pull and alter the speed of the Earth's orbit, slowly shortening the length of the year. And by then, by the mid-1800s, scientists knew enough to know that that was not happening. So this theory then, as creative as it was, had to be shelved. So then Helmholtz, not one to give up, mind you, very great mind, proposes a new theory. He still says it's the kinetic energy of motion, but now not from stray objects and meteors hitting the sun, but from the motion of the outer layers of the sun itself if it slowly contracted inward under its own gravity. Then that moving matter as the sun shrunk inward could give enough kinetic energy that could then be turned to heat and light energy to supply the sun. And he in fact calculates that if the sun contracts by about 1 inch every 3 hours, that could supply the needed energy. So what are the good points of this theory? Well, the sun could actually contract this way for millions of years. It was big enough to do that. Again, remember Cassini's calculation of the distance and People's calculation of the diameter of the sun. And then you see how science progresses, how interconnected everything is, how people stand on the shoulders of other people to make advances. And another good point of this theory is that there would be no increase in the mass of the sun, and so no effects on gravitation. Now, what are the problems with this theory? Well, the sun must have been much larger in the past. If the Earth is indeed millions of years old, the sun would have been very big before then. Now, the age of the Earth could be calculated, or at least a maximum age, because the Earth, it was felt at that time, had broken off from the sun, and it would have had to have broken off when the sun was 186 million miles wide. That is then going from one side of the sun to the other. That's what now gives us the current distance between the Earth and the sun of 93 million miles. And given the present size of the sun, that would mean that that happened 100 million years ago. Remember, in the 1600s, people thought the Earth was a few thousand years old. By 1750, they thought it was a few million years old. By the time of Helmholtz, people now thought that 100 million years was too young. And so, this was now an impasse between biologists and geologists who thought the Earth had to be more than 100 million years old versus physicists and astronomers. Helmholtz's theory of solar contraction was the best available, and it was actually the leading scientific theory for about 50 years as no other explanation was available, but biologists and geologists vehemently disagreed, saying that according to their theories, the Earth needed to be older. So, what if the sun was made of a different kind of matter? Because Helmholtz was doing his kinetic energy calculations based on matter like the matter we have on Earth. then potentially, if that matter gave off more energy, its contraction could be slower and the Earth could be older. So how could we figure that out? We can't get a piece of the sun. All we have to study is sunlight. But it turns out the intellect that Allah subhanahu wa ta'ala has given us is amazing, and that was enough. And we will try to understand how it was enough in the next episodes, inshaAllah. Salamu alaikum.